Okay, so for our Chem CP students, this is the homework problem that was assigned to you yesterday that's due today. What I want you to do is to get out your homework and exchange your homework papers. Make sure your name is on your homework paper. You know how to grade the papers. We're going to go through that. The substitute could, if he or she would, pause the video until everyone has exchanged their papers. All right. Now that everybody's exchanged their papers, you need to make sure that you have written your name at the bottom right-hand corner of the paper you're grading, and that you put a circle around it. And we'll start trying to solve this problem. Now, the solution process that I have taught you, 2 weeks ago before you went on spring break, and we went back over it again yesterday, was that you start by writing a list of knowns and unknowns. Let's see, where's the notes I did on that yesterday? Or it would be your day before yesterday now. Here we go. So you want to write a list of knowns and unknowns first. So let's read through the problem and see if we can find the knowns and unknowns here. So we have a tanker truck with 28.2 moles of gas. Well, that is a known. So we've got N, which is the symbol for moles. N equals 28.2 moles of gas. And then we've got a temperature at 35.0 degrees C. And we repeatedly stated that you can't calculate gas laws or calculate with gas laws using degrees C. You have to convert that to Kelvin. So you'll have T equals this temperature, which also equals then a Kelvin temperature. And then you have a volume, and that's the variable capital V. Of volume equals 1.274 liters. And then it asks what's the pressure inside, so you'll have a capital P for pressure followed by a question mark. So those variables will look like this. N is 28.2 moles, temperature is 35.0 degrees C, which is also equal to 308.2 K, and we got that by doing the math. We took that 35.0 degrees C and adding 273.15 to that. We get 308.15. We've got an empty slot above the 5, so the 5 gets rounded off. Our final answer is 308.2 K. So that's where we get this from. Anytime you're converting from degrees C to Kelvin, you add 273.15 to it, and of course if you're going back the other way, you subtract 273.15 to it. So then what we have to find now is an equation that fits these variables. And the only one of the equations that we've dealt with so far that would fit these particular variables is the ideal gas law. And the ideal gas law that I gave you yesterday was PV equals nRT. Okay, so we've got P, V, N, and T. We need to know what R is. Well, R you always have, because R is a constant that is listed on your test references. And the test references on the very first page have 6 different R's. And what you have to do is to figure out which version of R you need to use. So what we need to do is find a version of R that has the same variables listed in the problem. Well, we've got not variables, but the units of measurement. So we've got moles, and we've got Kelvin temperature in liters. And so what we need is a version of R that has moles, Kelvin, and liters. Well, we have 4 different versions of R that have moles, Kelvin, and liters. So we have this one, moles, Kelvin, liters. We've got this one, moles, Kelvin, liters. This one has moles, Kelvin, and liters. And this one has moles, Kelvin, and liters. So you can give me the answer using any one of those 4. Okay, so as you correct the paper you're grading, you have to look for the correct version of R they're using, one of these 4, and use it properly. I want to show you how to solve for all of those here. What I did here is to list all 4 versions of R. You don't have to do that. On your paper, the paper you're grading, they need to have R as one of these 4. Okay, so look on the paper you're grading and make sure that they have one of these 4, not all 4, just one of the 4. And it has to be the whole number with the units of measurement. The whole number with the units of measurement. The entire number with the units of measurement. Okay? Any one of these 4 is fine. Alright? So let's go ahead and give a point value to this. If they have listed their knowns here, the N will be worth 1 point. the T. I'm going to give T worth 2 points because they need to have converted that to Kelvin. So they get a point for writing T equals and another point for writing 308.2 K. Volume is going to be this capital V equals this number, liters. All of that is equal 1 point. P with a question mark after an equal sign, that's worth a point. The conversion over here to go to Kelvin, that's worth a point, where they have to add these two numbers together. And the fact that they rounded it off properly is worth a point. Okay? And any one of these versions of R, if they wrote the entire number with all 4 units of measurement, that's worth 1 point. Now let's go down and start actually solving or beginning to solve the problem. So the next thing they have to do is write the actual equation. So in this case, our actual equation is PV equals nRT. It's required in this class that you actually write down the equation that you're going to use. And so we're going to give a point for writing down that equation correctly. All right. Now the next step is they have to substitute known values where they can in the equation. What's going to happen is they've got 4 different versions of R to choose from. Now P, we don't know. So there's a question mark here for P. So P is just going to be listed P in the solution of the equation. We're going to multiply that times the volume here. And the volume we said is 127.4 liters. That's got to go right there. So this is for everybody. P times 127.4 liters. And then on this side of the equal sign, 28.2 moles is what N is. So N is up here, 28.2 moles. You list it like this. MOL is a shorthand for moles. You can use MOL or MOLES. It's fine. And this is where we're going to plug R in. And we're going to use 4 different versions of R here. I'm going to solve for all 4 of those for you. But your temperature has to be 308.2 K. Okay? So the student whose paper you're grading has to have all of these things in there. They have to have P. They have to have the volume. They have to have N. They have to have the temperature. And when we put in the R, they have to have all of that. Okay, so let's start with the first one here. So if you're grading a student's paper and they have this number with all these variables right in here, that's worth a point. So I'm going to put that in here on this paper. 0.08206 liters times atmospheres over Kelvin times moles. Okay. To solve for P then, we have to isolate P, get it all by itself. And the way we do that is to, since this is multiplication, P times this, to undo multiplication, you use division. And so we're going to multiply this times 1 over 127.4 liters. Putting this on the top by putting this over 1 and this on the bottom. That allows us to cancel this entire thing here and leaves us P by itself. Okay? So they have to do this to isolate the unknown. That's going to be worth a point for correctly isolating the unknown on this side. The thing to remember that they also have to do is they have to, whatever you do to this side of the equation, you have to also do to this side of the equation. So we're going to also multiply by 1 over 127.4 liters on this side. So that's worth a point for putting that over there. Okay? Now we're ready to go about actually doing the solving step. Okay, so what we've done so far, we listed our knowns and unknowns. We chose and wrote the correct equation, PV equals nRT. We plugged in the known values. Okay, we plugged all those in there, and now we've isolated the unknown. We're ready to solve the problem. So our first step here is to cancel the units. All right, so we have, let's put these two numbers here over 1. Putting a number over 1 in a fraction doesn't change the value, but it helps us to see clearly what units of measurement can be canceled. So moles are on the top here and moles are on the bottom here. Those can cancel. Let's see, liters are right here and liters are down here. They can cancel. All right. Let's see, I've got Kelvin right here and Kelvin right here. And those temperature units can cancel. All right, so if they've properly canceled everything now, okay, all the cancellations are done properly. All right, we're going to give that, let's see, let's give that 2 points, okay? All the cancellations are done properly. That's worth 2 points. All right, the next step then is to actually do the math for this problem. So we're going to multiply this number times this number times this number. Then we're going to enter our equals on the calculator and then divide by that number. Now, what we have, well, actually before we do that, we should check and make sure we have the right units, because we got atmospheres here, and that is one of the measurements of pressure. So if P on this side matches up with the units of measurement on this side, we know we've probably got the right thing going on. We probably set it up properly. Okay. If you want to know what pressure units are acceptable, they're all right here on the front page of your test references. Okay. Atmospheres, kilopascals, torr, millimeters of mercury, they're all acceptable units of pressure. Okay. So now we're ready to solve the problem. We have to keep P because we didn't cancel P on this side. P equals, and we do all this multiplication. And let's see, I think I already did the math someplace. Here we go. For this, in this case then, we have 5.399625 294 atmospheres. Now you may have fewer digits out here because your calculator may not go as far, but we have all, that's the correct unrounded answer. That unrounded answer is required with the measurement unit, and that's worth a point. Okay. We're going to look now at all of our measured or calculated numbers in the problem, and we see that the number with the least number of significant digits is this one right here, 3 digits. So our final answer needs to have 3 digits. We're going to count 1, 2, 3. Those are our significant digits. Everything after that is insignificant. We underline them. We draw an arrow to show that we're rounding off. And then we write the final answer is 5. This 9 makes this 9 round up to a 10, which then has a 1 that carries over to this 3, making that a 4. And the 10, all we've got left from that is that 0. So the correct answer is 5.40 atmospheres. And that's your final answer. Okay? All right. What I'm going to do is I'm going to stop this video and ask that the substitute then go to video number 2, and we'll solve for the next version of R.